Hello, everyone. So far in this course, we've explored how to build web pages using HTML, CSS, and JavaScript, focusing on explicit instructions. Today, we're taking a fascinating turn into a different paradigm: machine learning. Machine learning. Instead of you writing every single rule, machine learning empowers computers to learn directly from data. Think of it as teaching a computer to recognize patterns and make predictions, rather than programming it with an exhaustive list of if-then statements. This opens up incredible possibilities, and we'll start by understanding how it differs from traditional programming. Let's dive deeper into that distinction. In traditional programming, you, the developer, write explicit, step-by-step instructions for the computer to follow. For example, if you're building a spam filter, you'd code rules like, if subject contains free money, mark as spam. With machine learning, it's different. You feed the machine examples, thousands of emails labeled as spam or not spam, and the algorithm learns to identify the characteristics of spam on its own. Here, the data itself becomes the program, allowing for adaptability and handling of complex scenarios that are difficult to define with fixed rules. This fundamental shift enables machines to tackle problems we couldn't solve before. Now that we understand the core difference, let's explore the main types of machine learning. The first, and arguably most common, is supervised learning. Imagine a student learning with a teacher by their side. In supervised learning, the algorithm learns from labeled data, meaning each piece of input data comes with its correct output. For instance, you might show it thousands of images, each clearly labeled cat or dog. The algorithm then learns to map inputs to outputs. This is used for tasks like classification, predicting a category, or regression, predicting a continuous value like house prices, effectively predicting outcomes based on past examples. Moving on from having a teacher, we have unsupervised learning. As the name suggests, here the data is unlabeled. There's no correct output provided during training. Instead, the algorithm is tasked with finding hidden patterns, structures, or relationships within the data all on its own. Think of it like giving a child a box of assorted toys and asking them to sort them into groups without any instructions. Common applications include clustering, where it groups similar data points together, perhaps segmenting your customer base, or dimensionality reduction, simplifying complex data while retaining important information. It's about discovering the inherent organization of data. Finally, we come to reinforcement learning, which is perhaps the most intriguing. This type of learning is inspired by how humans and animals learn, through trial and error, by interacting with an environment. Here, an agent performs actions in an environment and receives rewards for desirable actions and penalties for undesirable ones. It's like training a dog with treats. Over time, the agent learns a strategy or policy to maximize its cumulative reward. This is the technology behind self-driving cars, game-playing AI like AlphaGo, and robotics, where continuous learning and adaptation are crucial. Machine learning isn't just a theoretical concept. It's deeply integrated into our daily lives, often without us even realizing it. Think about personalized recommendations on streaming sites or e-commerce sites. That's ML, predicting what you'll like. Natural language processing powers voice assistants like Siri and Alexa and translates languages. Computer vision enables facial recognition, self-driving cars, and medical image analysis. And crucial for finance, ML is vital for fraud detection, identifying suspicious transactions in real time. These are just a few examples of how ML is transforming industries and experiences. So, how do we actually build these intelligent systems? It typically follows a structured workflow. First, we need data collection and preparation. This is often the most time-consuming step, ensuring we have clean, relevant data. Next is model training, where we feed the prepared data to an algorithm to learn patterns. Then we move to evaluation and tuning, meticulously testing the model's performance and adjusting its parameters to optimize results. Finally, the model is ready for deployment and monitoring, integrated into a system where it can make predictions in the real world and continuously monitored for performance. Machine learning offers incredible power, but it's important to understand both its benefits and challenges. On the plus side, ML automates complex tasks that would be impossible for humans, and it extracts deep insights from vast amounts of data, revealing trends we'd otherwise miss. However, it requires quality data and expertise, garbage in, garbage out. We also face significant ethical concerns, such as addressing bias in data leading to unfair predictions and ensuring data privacy. Understanding these aspects is crucial for responsible and effective application of machine learning in any field.